You're locked in for another deep dive, and today we're setting our sights high. Literally, we're going to unpack the aerospace composite ducting market.
Sounds good. It's a fascinating area.
Yeah, we've sifted through a pile of articles, market research, trying to bring you the core insights, What's really powering this market, and I guess what does it mean for the aircraft of tomorrow?
Think of it as your shortcut to understanding a key bit of aviation innovation.
Exactly.
That's right. We're not just skimming the surface here. Composite ducting, these are essential systems for air conditioning, ventilation, even the fuel lines inside a plane. And they're undergoing a pretty significant evolution.
Right. Driven by what exactly?
Well, it's driven by the need for materials that are not just lightweight, crucially, but also incredibly durable. And they need to deliver, top-notch performance.
So forget those heavier metal tubes of the past then.
Pretty much. These new composites, often made with things like carbon fiber or fiberglass woven into strong polymers, they offer some really serious advantages, especially when the goal is building more efficient aircraft.
And that's really the heart of it, isn't it? The constant demand for better fuel economy, stricter environmental rules. That's really pushing this change.
Absolutely. Those are the engines driving it.
We even saw big players like Boeing and Airbus actively putting composite ducting into their newest models just last year. That felt like a really tangible sign of this shift, taking flight.
It was. And the numbers, well, they paint a clear picture of this momentum, too. Our analysis suggests that in 2024, the global market for this stuff was valued at roughly $1.5 billion.
Okay, $1.5 billion. And looking forward.
Looking ahead, projections show it climbing to nearly $2.2 billion by 2032. That works out to a compound annual growth rate, a CAGR, of about 4.5%.
4.5%. Now, that might sound maybe steady rather than explosive.
Well, yes, but you have to consider this is a highly regulated, safety-critical industry. Steady growth like that, 4.5%, it actually signals a fundamental shift in adopting these materials. It shows real long-term confidence.
Confidence in the tech. And maybe opening doors for even more disruptive stuff down the line.
Potentially, yes. It lays the groundwork.
Okay, let's dig into that consistent climb then. What are the key trends we're seeing pushing this market forward?
Well, a primary driver, like we touched on, is just the increasing integration of composite ducting in the next generation aircraft.
Yeah.
The industry's focus is really on achieving this powerful combo, boosting fuel efficiency, enhancing passenger comfort significantly, and of course, environmental sustainability.
Right, so it's not just about cutting fuel bills, although that's massive. How does using composite ducting actually make things more comfortable for passengers? Is it noticeable?
It's all kind of interconnected. Lighter aircraft can often mean a smoother, quieter ride, less vibration. Plus, the design flexibility you get with composites lets engineers really optimize the airflow inside the cabin much better. Better air distribution, just a more pleasant environment overall.
Makes sense.
But yeah, the weight reduction aspect, that's still paramount for fuel efficiency. Every single kilogram shaved off makes a real difference in fuel burn and, naturally, operating costs for the airlines.
It's like a chain reaction of benefits.
Exactly. A cascading series of benefits.
Less weight, less fuel, lower costs. Simple, but powerful. And it's not just the main structure anymore, is it? These composites are popping up elsewhere.
Precisely. Initially, yeah, composites were mainly in the big airframe structures, but now we're seeing them used more and more in critical systems, air conditioning, fuel lines, even hydraulic systems.
So really spreading throughout the aircraft.
Definitely. And this spread is really being enabled by some pretty cool advancements in how they're actually made.
Ooh, interesting. Can you give us a peek behind the curtain there? What kind of manufacturing tech are we talking about?
Sure. Think about something called autoclave processing. It's basically like a very high-tech industrial-strength pressure cooker.
Okay.
It uses intense heat and pressure to make sure all the layers of the composite material bond together perfectly, right down at the molecular level. You get incredible strength and reliability.
Wow. Sounds intense.
It is. And then you've got 3D printing or additive manufacturing. That's letting manufacturers create incredibly complex ducting designs. Things that perform better, can be cheaper to make, and produce way less waste than traditional methods.
Right. Additive is huge everywhere now.
It really is. And what's particularly cool here is how these advanced manufacturing techniques directly help the push for better aerodynamics and that enhanced cabin comfort we mentioned.
So lighter, more fuel efficient, maybe comfier flights. Partly thanks to these manufacturing upgrades. And you mentioned composites in aircraft interiors more broadly, too. How does that connect?
It's all part of the bigger picture in aircraft design. The more lightweight, durable materials you can use everywhere, interior panels, seats, and yes, the ducting. The bigger the total weight savings and the better the overall performance.
It all adds up.
It all contributes to that main goal, maximum fuel efficiency and cutting the environmental impact.
Okay, let's pull back a bit now. Look at the geography. Where's most of this action happening right now? Which regions lead?
Right now, North America is definitely the leader. They hold nearly 40% of the global market share as of 2024.
40%, okay. Why so dominant?
Well, it's largely down to the strong presence of the major aerospace manufacturers there, plus a really skilled workforce. You've also got significant defense and commercial aircraft production, and just the advanced infrastructure that supports developing and using these materials.
So the established giants are mostly North American. What about the rest of the world?
Europe's in a strong second place, holding around 30% of the market. That's driven by big aerospace hubs in places like France, Germany, the UK, plus a really strong regional push, regulations even, towards cutting aviation's carbon footprint.
Okay, makes sense. Europe's often ahead on environmental regs.
They are. But what's really worth watching is the anticipated rapid growth in the Asia-Pacific region.
Ah, yes, the growth engine. What's driving it there in this specific market?
It's mainly the massive boom in demand for air travel in developing economies like China and India. Their middle classes are growing, air travel is becoming more accessible, so their aviation sectors are just taking off.
Right, more planes needed.
Exactly.
Yeah.
And that, combined with their growing ability to actually build commercial aircraft locally, means they need more advanced components like composite ducting.
So, local demand meeting local supply eventually.
That's the trend. And we're also seeing rising demand in the Middle East and Africa, too, as they invest in upgrading their aviation infrastructure.
Okay, so North America leads now, but the map is definitely shifting. Let's get down to brass tacks. Who are the main companies actually making this stuff?
Yeah, the market's pretty competitive. Several key players. As of 2024, a UK company, Senior Pillock, holds the biggest slice, around 7.5%.
Okay, Senior Pellet, who else?
Then you've got AIM Aerospace and Arrowhead Products, both US-based. They're close behind with about 5.6% and 4.8% market share, respectively. These are some of the leaders really pushing these lightweight, high-performance solutions.
Right, let's look at them a bit closer. Senior Pillock, what makes them stand out?
Well, Senior Pillock has a really long history in aerospace. Lots of experience making complex ducting for all sorts of aircraft. They're known for innovation, especially in high-temperature and fire-resistant composites.
Critical stuff for safety.
Absolutely. Makes them a key supplier for both commercial planes and defense projects, where those properties are just non-negotiable.
Got it. And AIM Aerospace, what's their specialty?
AMO. Aerospace focuses heavily on advanced thermoplastic composites. These materials offer better durability and flexibility compared to some traditional composites. That's increasingly important in modern designs that need to be more adaptable and resist wear and tear.
More durable, more flexible?
Go ahead.
And Arrowhead products.
Arrowhead has built a great reputation for custom-engineered ducting. They cater to both military and commercial needs, and they have particular expertise in specialized systems. Things like environmental controls for the cabin or cooling-sensitive electronics. Vital stuff.
Avionics cooling, yeah. Can't have those overheating.
Exactly. And what's really interesting is that all three of these top companies are pumping significant money into ongoing R&D.
Right. And what's the main goal of that R&D push? What are they trying to achieve?
It's all about reading the industry's constantly evolving and, frankly, increasingly tough requirements. So pushing for even more weight savings without losing strength, getting better resistance to extreme temperatures, improving the aerodynamics of the ducts themselves.
It never stops.
Never. And all this R&D activity, it links directly back to that big trend, sustainable aviation, making aircraft lighter, more fuel efficient, less impactful on the environment.
So the materials themselves aren't static. They're constantly improving. You mentioned earlier a shift towards carbon fiber reinforced composites and these thermoplastic polymers. What's the big deal with them?
Their crucial advantage, really, is their incredible strength-to-weight ratio compared to metals. They provide the needed structural integrity for tough aerospace jobs, but cut down the weight significantly.
Which we know saves fuel.
Exactly. Plus, these advanced composites are super durable. They inherently resist the extreme conditions planes face, big temperature swings, moisture, long-term effects of corrosion and fatigue.
Built to last, basically.
That's the idea. And like we said, companies like Senior Pillock and AIM Aerospace are really leading the charge in developing and using these advanced materials. Just to give you a sense, carbon fiber can be like 5 times stronger than steel, but way lighter. allows engineers to design thinner, lighter ducts safely.
Wow, 5 times stronger. And you also flagged 3D printing earlier. How is that changing how composite ducting gets made?
Oh, additive manufacturing is truly shaking things up. It lets you create these incredibly intricate, complex ducting shapes that would be super difficult, maybe even impossible, to make the old way.
Through traditional subtractive methods, you mean?
Right, carving things out of a block. Additive builds it up layer by layer. This complexity can mean better airflow inside the ducts, maybe even further weight reduction. Plus, 3D printing can cut down material waste hugely, potentially lower production costs, and drastically shorten the time it takes to get these specialized parts made.
Faster turnaround times.
Exactly. Arrowhead Products is a good example of a company really using 3D printing effectively.
It sounds like we're moving towards ducting that's almost perfectly tailored for each specific plane model.
That's the direction, yeah. And that level of design freedom, that customization, it can really boost the aircraft's overall performance.
Makes sense.
And another really interesting and increasingly important development is the focus on recyclable composite materials.
Recyclable composites. Now that sounds like a big step for sustainability.
It really is. Thermoplastic composites especially show a lot of promise for being recycled when they reach the end of their life.
Yeah.
That's becoming absolutely vital as the industry faces tougher environmental rules and, frankly, more demand from customers and society for greener flying.
Right, the pressure is on. Okay, so we've hit the trends, regions, players, tech. Let's talk growth opportunities. Where's the upside here?
Well, the constant progress in material science and design engineering, that's a huge opportunity in itself. As we've talked about a lot, composite ducting is key for cutting aircraft weight.
Which means better fuel efficiency, better performance.
Exactly. Tangible benefits. And this links directly to the aerospace industry's big sustainability push, right?
Absolutely. Lowering emissions, reducing operating costs.
Precisely. Using lightweight composites is a direct answer to that push. And it's not just weight. These advanced materials, carbon fiber, high-performance thermoplastics, they're just tougher.
Yeah.
Better resistance to heat, corrosion, fatigue.
So longer lifespan for the parts, less maintenance maybe.
That's the potential benefit, yes. Could lead to longer component life and maybe reduced maintenance needs over the aircraft's lifetime.
And the fact that more people are flying globally must be a factor too.
Oh, absolutely. The rising demand for air travel, especially in those fast-growing economies we talked about, Asia Pacific, other emerging markets, it just means more modern and efficient parts are needed.
A bigger market overall.
Definitely. And the big picture goal, developing that next generation of sustainable, super efficient aircraft, that's the ultimate driver. It forces manufacturers like Boeing and Airbus to invest heavily in lightweight materials like composite ducting for their new planes.
Okay, it sounds quite promising, but surely there are challenges, right?
Yeah.
What are the main headwinds?
Oh, for sure. There are definitely significant challenges. One of the biggest is simply the high cost. Producing advanced composites like CFRP and the specialized, often complex manufacturing processes needed, it's expensive.
Right. Cutting edge usually is, initially anyway.
Yeah. And that higher upfront cost can be a real barrier to wider adoption, especially for smaller companies in the supply chain, or maybe airlines that are more budget-focused.
Makes sense. What else?
The really strict certification process, that's another major hurdle. Aviation authorities, the FAA in the U.S., EASA in Europe, they have incredibly tough safety standards. Everything has to be proven safe.
And composites behave differently than metals they've used for decades.
Exactly, because the properties are different from the metals the industry has, tons of experience with. Getting that certification can take a long time and cost a lot of money. It needs exhaustive testing and validation.
So you can't just swap it in. You have to prove it works safely.
Rigorously prove it, yes, to the highest standards. And finally, maintenance and repair can be trickier with composites compared to metal ducts.
How so?
Well, while they're very durable, if damage does happen, fixing it might need specialized techniques. That could potentially lead to higher repair costs and, crucially, longer aircraft downtime. And airlines hate downtime.
Yeah, time on the ground is money lost. So higher costs, tricky certification, potential MRO challenges, important things to consider. Now, looking even further ahead, any specific future developments we should keep an eye on?
Yeah, one really exciting area is the work being done by companies like Eaton. They're looking to replace traditional aluminum ducting with advanced carbon-reinforced PK composites. That's polyether ketonic ketone.
PKK, okay, another advanced material.
Exactly. And PKK boasts Really superior strength, exceptional durability, and very high temperature resistance. Makes it a fantastic potential replacement for metal in critical air deck systems.
So PK composites, what are the main benefits there? Still weight reduction.
That's the big one, yes. Further significant weight reduction, which again means better fuel efficiency, smaller environmental footprint. Eaton's work really shows that constant drive to replace heavier, older materials with these advanced lightweight options.
Pushing the boundaries again?
Right. This kind of innovation could genuinely revolutionize the market and really help hit those big sustainability goals for aviation. PK, for instance, it's a high-performance thermoplastic known for great chemical resistance too, and it handles really tough operating environments.
So we might see PK becoming much more common in the next wave of aircraft ducting.
That's definitely the expectation in the industry, yes. And as more companies invest in R&D for advanced composites and get better at the manufacturing techniques, the hope is that production costs will gradually come down over time.
Making them more accessible.
Exactly. Making these high-performance options more economically viable, driving even wider use across different types of planes, and that relentless focus across the industry on cutting emissions, optimizing fuel burn. That's just going to keep fueling the search for innovative materials like PK.
It definitely sounds like the future is lighter, stronger, and greener for aerospace ducting.
Absolutely. The overall direction is pretty clear. Ongoing material science breakthroughs are the key, pushing the whole market towards better efficiency and environmental responsibility.
Okay, so to wrap this all up then, we've seen the aerospace composite ducting market is growing significantly, steadily. It's fundamentally driven by that relentless aerospace quest for lighter, more fuel-efficient, and ultimately more sustainable aircraft.
Couldn't have said it better.
Continuous innovation in materials science, advanced manufacturing. That's really at the heart of this transformation. And while North America leads today, keep an eye on Asia Pacific for rapid growth.
Definitely the region to watch.
The key players, they're locked in this competitive race, constantly innovating, pushing the tech forward. And yeah, there are challenges, costs, certification hurdles, but the future looks really bright, especially with exciting developments like PK composites coming through.
That's a great summary. It captures the key dynamics and where this critical bit of aerospace tech is headed. That drive for efficiency just ensures composite ducting will keep evolving.
It really makes you think, doesn't it? How these very focused advancements in materials in a super specialized field like aerospace, how they might ripple outwards. Consider how these innovations, first developed for extreme conditions, might eventually pop up in completely different industries you're familiar with, bringing unexpected benefits. What other sort of niche markets out there might be going through similar deep changes, all driven by this quiet revolution in material innovation?
That's a good question.
Something to chew on. Thanks for taking this deep dive with us today.